Okay, we're back again, and this time we will be dealing with Ohm's law, which gives us the relationship between voltage and current flowing through a conductor or in a circuit. Now, Ohm's law states that the current flowing through a conductor, I can either say flowing or passing through a conductor, is proportional, that's it directly, to show it directly, is proportional to the potential difference between its ends. Potential difference between its ends, provided temperature and physical, that's temperature and other physical conditions, are kept constant. Now, don't get confused when I say potential difference. I simply mean voltage. Don't be confused between voltage, EMF, and potential difference, which I will abbreviate as PD. Potential difference. EMF is electromotive force. Um, the EMF in a circuit is the total potential differences in the circuit. That's at each point in the circuit. That the total voltages and everything in the circuit. So it simply tells you that if I have a conductor, let's say this is a wire, the current flowing through this conductor is proportional to the potential difference between the ends of the conductor. That is, one will be positive, one will be negative. That is just trying to show you that one side is providing, one side is receiving. So one side will be at the normal circuit, one side will be at 0 volts, the other one will be at a certain volt. So that's the potential difference, the difference in their potentials. That gives you is directly proportional to the current. That gives us our current I to be directly proportional to potential difference, as our voltage V. That gives us V is also, you see the same thing as I, gives me my V to be equal to my I. So I have to introduce a constant known, I'll call it ohmic constant or ohm constant, which I will take it to be R. So V will be equal to I R. R here stands for resistance. That's what R there stands for. It stands for the resistance in either the resistance of the conductor or the resistance in the circuit as a whole. So when you say temperature and other physical conditions, at high temperature, resistance of conductors, especially the metal ones, the resistance increases, so it will affect this law. So that was provided temperature and other physical conditions are kept constant. Now, this law, which says that V is equals to R, can be used to determine the voltage or current either in a circuit or being provided by a battery. Assuming I am told to find the voltage in a circuit when I've been given the current, all I need to know is to get the internal resistance, because sometimes when it comes to a cell or a battery, this capital letter R is being used as R, that's internal resistance. So this one is external resistance outside the battery, that's moving in a circuit. Now, when we were talking about current, we simply mean the flow of electrons, just electrons flowing. So electricity is basically electrons. That just basically electrons. So assuming I have a battery of 3 volts is connected to a resistor. Let's say a resistor of 10 ohms. I'm asked to find the current flowing through the resistor. So as simple as this looks, it's to be advisable that you understand what you are asked to do. It's better if you understand what you are asked to do. Good. Now we already have our voltage as 3 volts. We have our resistance as 10 ohms, and assuming this is our battery, and it is connected to a resistor, and the battery is of 3 volts. The resistor has a resistance of about 10 ohms, as we were told. Now we should note that the current we're looking for is not the current of the battery, but is the current flowing through the circuit. That's through the resistor, as resistor is the only component apart from the battery here in the circuit. So the current we are finding is not the current of the battery. It is the current that is flowing through the circuit. That is the current the battery is giving out into the circuit, not the battery's current. So relating this to our equation, we have our V to be equal to IR. So our V is therefore 3 as 3 volts. Our current is unknown. We'll leave that as I. And our resistance is 10 ohms. Dividing both sides by 10 to get my current on its own, I have my current to be equal to 3 over 10, which is equal to 0.3 amps. Now, if you notice, we did not measure our current in volts per ohms. We didn't do that because current as itself is a fundamental quantity that already been I would say it has already been postulated by someone named Ampere, and so they decided to name it after him. So that's the reason why we don't make it of volts per ohm for our current. So this is just I would say the basic thing on the use of Ohm's law. If I have a battery of let's say 10 volts, if I have a battery of 10 volts and it's connected to 2 resistors, yes, this resistor is of 2 ohms, this one is of 5. If I'm told to find the current flowing through, let's call this A and B, through resistor A, it's simply going to be that my V will be equal to my IR. That's the general formula for all of them. But when I'm looking for A, it is going to be V equal to IRA, because I want to find the particular current flowing through the resistor A. My voltage is 10, my current is I, and my resistance for this one is 2, so 2 ohms. Therefore my I is equal to 10 divided by 2, which gives me 5 amps. That's the voltage flowing through A. Now the voltage flowing through B will be given by IRB. That gives me 10 is equal to I times 5. So that's I. My I would now be 10 divided by 5, which will be equal to 2 amps. So that basically, now if you've noticed, when I was solving these 2 questions, I looked for my current. I didn't look for voltage. Assuming I don't know this, assuming this 10 volts isn't given, unless, okay, let me just make another question. But a battery has a current of 5 amps, and let's say the resistance in the circuit is 100 ohms. Find the voltage. We do not know the voltage. We don't know. But to find the voltage, our V will be equal to IR, which will be equal to our I is 5 times our R 100. This is 500 volts. We can equally find the resistance of a battery using V equal to IR. The Ohm's law, this refers to the resistance, internal resistance of a battery, but this refers to the external resistance of the circuit, not the external resistance outside the battery, and this refers to the sum of all the resistance both inside and outside the battery. That's the internal resistance and the external resistance. This can also be written as I to be V over R plus R. If you notice, I've been using V throughout, but when I'm talking about potential difference, I told you that the EMF is the sum of the total potential difference. So it's alright if you use E because it's still the sum of the total potential difference. So even saying this is proportional to E, or even having E to be equal to IR, it's still the same thing as V equal to IR. So all things being equal, I can still put this as E over R plus R. It's still valid. So this and this is the same thing, but it's just try to put the E for specification purposes. Okay, that's for that, and thank you.